Okay, and our next problem, it says a certain group of people, or in a certain group of people, of 50 people, 16 have blonde hair and 20 have blue eyes. And exactly 9 of these persons have both blonde hair and blue eyes. And it wants us to first draw a Venn diagram to illustrate this situation. So we've already got a rectangle created for the universe, and we have 2 overlapping circles drawn inside of them, labeled BH for blonde hair and BE for blue eyes. On these, what you really want to do is kind of work from the inside out. So I'm going to start with the fact that exactly 9 of these people have both of these features. So that's going to go in that overlapped area. So I'm going to write a 9 inside there to represent that there are 9 people in here. Okay, that's the number of elements in there. So I don't have all the 9 people's names written in there. We've kind of switched to the number that I'm writing in there just means that's how many people fall in there. Okay, so then if we go back and we say 16 people have blonde hair, that means that inside this blonde hair circle, this BH circle, there have to be 16 total people. But what's important to notice is that there's already 9 people inside that circle because they're in that overlapped area. So how many people can go in this other like crescent-shaped portion of this? So we need to take 16 minus 9. There must be 7 people out here in this other part of that BH circle because now there's 7 people in that crescent area and 9 people in the overlapped area, so there are 16 total people in there. So same thing is going to work for the fact that if there's 20 people who have blue eyes, if we go to the BE circle, there need to be 20 total people in that circle, but there's already 9 people in it. So out here in this other area, we need to do 20 minus 9, so there must be 11 people over in this other portion of that circle. And then, does that even add up? That doesn't add up, right? So far we have 7 plus 9 plus 11 people accounted for. But that doesn't add up to 50. Agreed? That's only 27 people. So there must be some people in this universe, in this group of 50 people, that happened to not fall into any of these categories. So out here in the U part that's not inside those circles, we need to take 50 minus 27. That means that there are 23 individuals out here. And now I've got all 50 people accounted for, and we could answer some questions about that. So it says, determine the number of people without blue eyes. So this would be like the set, if I wanted to write it as this, it would be the set BE complement, the complement of having blue eyes, the people who do not have blue eyes. So it needs to be everyone outside of the blue eye circle. So that's the red circle that I created. So everyone outside of that would be the 7 people and then the 23 people. So it looks like there were 30 people outside of that circle. Determine the number of people with blonde hair or blue eyes. So I'm going to write this as BH union BE. How many people have blonde hair plus the amount of people who have blue eyes, basically, or. So let's see, all the people inside of these circles anywhere. So we have 7 and 9 and 11. If we added all those together, then we would get the amount of people everywhere inside those circles. So that's that 27 people, and that makes sense. That was what we just said when we were first started drawing this. We were like, oh, there's 27 total people inside those circles. So 27 people have blonde hair or blue eyes, or both. That's fine. That qualifies as a union. and determine the number of people with neither blonde hair nor blue eyes. So nowhere inside these circles, you don't have either of these qualities. We already know what that is. We calculated it, but not formally. We didn't name it. That would be those 23 people totally on the outside of these. So this would be BH complement because they don't have blue hair, and or intersect the BE complement because they don't have either of these. You do not have blonde hair and you do not have blue eyes. So that is 23 people. Okay, so this leads us to the idea of, we're like, how many instead of what are the elements. So that leads us to another definition word, the cardinality, which is the number of elements in your set. So all of these we were just doing were technically called cardinalities. The cardinality of a set A is denoted as in, lowercase n, of, so parentheses, A. That's the number of elements in set A. So really what I should go back up and include on every one of these that we just did is I should include an in, a little in out in front of all these. Because I didn't want to know what the actual set was, and I'm going to put some brackets around them just to separate them out. So I wanted to know the amount of elements in those. I didn't want to know what the set itself was, what all the elements were. I just wanted to know how many. So there's kind of two different questions there. And we did talk about in a prior note section that sometimes you can have a lot of elements to list, and it could be easier to just simply say how many there are and not actually try to list them all. Okay, so this says if our next question is number 5. If we have a set A, which is the elements 5, 10, 15, 20, and 25, and a set B, which is the elements 30, 40, 50, and 60, find the following. So find the number of elements in set A. Well, there's 1, 2, 3, 4, 5 elements in set A. So I'm just going to say that the number of elements in set A equals 5. There are 5 elements in there. And what's the number of elements in set B? There are 1, 2, 3, 4 elements in set B. So if they want to know the number of elements in A plus B, that's just 5 plus 4, which is 9. How many elements, or what's the number of elements in A intersect B? So these, how many elements are in both of those sets? And if I look at them closely, not a single element overlaps. So there are no elements in both. So how many are there? 0. So notice my notation. If I'm talking about the number of elements, I can use a 0. If I was talking about what that set was called, I would use the empty set notation. What's the number of elements in A or in B? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now in number 6, we have 2 different sets. A is still the same set. A is 5, 10, 15, 20, and 25. But B has changed. B is now 10, 20, 30, and 40. The number of elements in A has not changed. That's still 5 elements. And the number of elements in B has not changed. That's still 4 elements. So the number of elements in A in A plus B has also not changed. That's 9. However, the number of elements in A intersect B has changed because now we have overlapping sets. The elements 10 and 20 are in common to both sets, so there is overlap. 2 elements overlap. So the number of elements in A intersect B is 2. What's the number of elements in A union B? So in this case, it becomes a little bit trickier because we have this overlap scenario. So let's remind ourselves in this one, what is the set A union B? Let's write them all out. The set A union B is 5, 10, 15, 20, 25. I don't list the 10 or the 20 again, but I can list 30 and 40. So how many elements are in that set? 1, 2, 3, 4, 5, 6, 7. So in this case, the number of elements in A union B is only 7 elements. So we have to be careful with our union cardinalities, okay? And this is really important. So it says if A and B are any two sets, then the number of elements in their union can be found by taking the number of elements in A plus the number of elements in B and subtracting out the number of elements in the intersection. So notice that's what happened in this last one. We took both of them added together was 9. So that was that was this part, the number in A plus the number in B. That was 9, but we subtracted off the 2 that were overlapped, and that gave us 7 to be left in the union. Right? Because you don't want to double count the 10 and the 20 in this case. They don't get double counted. So that leads us to the specifically, if A and B happen to be disjoint sets, so it should be plural, if they're disjoint sets, then the number of elements in their union is just the number of elements of each added together, because there is no overlap to subtract. If we would have done the original formula up here, we would have done the 5 plus 4, which was the 9. We would have subtracted 0 from it, and that's how we would have got to this other 9, because there is no overlap. So my hint is that it's always safe to use this first formula if you're trying to find the cardinality of a union. Just add the 2 together and then subtract off however many are in the intersection. You may end up subtracting 0 if they happen to be just disjoint, but there's no harm done there. It's not like you've wasted very much time by writing -0. But if there is overlap and you forget to do this part right here is key. If you forget to do that, then you're wrong. So I always just say better safe than sorry. Go ahead and write it down. If you happen to subtract 0, oh well, but that's how you will catch any that happen to have overlap.